and welcome to my YouTube channel, where every episode I take a physics topic and hopefully explain it in a really simple and understandable way. Now, some episodes are just going to be fun physics facts, but most I'm going to try and tie in to the current school curriculum. So when that's the case, I'm going to put the key stage in the episode title. Back on my momentum episode, we entered into the world of scalars and vectors. So I thought I'd do a separate episode just to double check we fully understand what they are. We measure physical quantities, where a physical quantity is like any physical property that we can quantify with a measurement. So it's a property of a physical thing that can be measured. Okay, so here's some examples of a physical quantity. We have temperature, length, mass, time, those kind of things. A physical quantity is always expressed as a numerical value, so a size plus a unit. Never forget about the unit! So like mass would be X number of kilograms, or temperature would be X number of Kelvin, or length X number of meters. You get it? These are all examples of physical quantities. And, as you've been noticing, the numerical value is always accompanied with a unit. You know me, love my units. You've always got to have units. Like, the velocity is 10 what? Meters per second? Miles per hour? I've got to know. And there are the SI units, which are the International System of Units. So these guys are the standard units of measurement that are used all around the world. And there are 7 basic units from which all other units are derived. These 7 are kilograms for mass, meters for distance, seconds for time, ampere for electric current, mole for the amount of a substance, Kelvin for temperature, and candela for luminous intensity. Yes, remember them all! So when you're asked to present your answer in SI units, always use one of these 7 or one that's derived from them. When I say derived, I mean like velocity's SI unit would be a combination of distance and times, so it's meters per second. Or force, which is measured in newtons. Now, newtons is an SI unit, but it's like a nickname, so to speak. So 1 newton is equal to 1 kilogram meters per second squared. So the SI unit technically is kilograms meters per second squared, but it's a bit long, so we've renamed it to newtons. Same with others like joules, pascals, watts, etc. Like, my full name's Rebecca, but it's a bit long, so call me Bexy. Alright, I think that's a pretty good foundation for scalars and vectors. We now know what a physical quantity is and what an SI unit is. So let's move on. Physical quantities are split into 2 categories, scalars and vectors. Scalar quantities only have a magnitude or size. Like if someone's mass was 60 kilograms, or the distance between 2 objects was 180 meters, or the temperature of the room was 24 degrees C. These are examples of a scalar quantity that just have a size. When you need to find the sum of a scalar, you literally just add them all together. So what is the total mass of 2 people where one person is 60 kilograms and the other is 50 kilograms? You just add them together to get 110 kilograms. Or like, how far would I have run if I ran 200 meters, stopped, and then ran another 300 meters? I would have run a total of 500 meters. Got it? Whereas vector quantities have a magnitude and a direction. Huh? Some examples of vector quantities are force, acceleration, velocity, momentum, and displacement. Recognize some of them? For these examples, you'd give your vector quantity as like force being 50 newtons downwards, or acceleration being 25 meters per second squared forwards, or velocity is 10 meters per second to the left, or displacement is 0.1 meters upwards. These are all examples of a vector quantity. Now maybe you finally know the difference between speed and velocity. 2 objects like cars may have the same speed but a different velocity if they are travelling in different directions. The direction for a vector can either be represented by an arrow or written in the description, but you have to be careful when drawing the arrows. Because they can represent magnitude too. So if you have two velocities and the first arrow is half the size of the second arrow, then this will mean that the first velocity has half the magnitude of the second velocity. They won't always just represent direction, so be careful when you draw them. There we go, the basics for physical quantities, SI units, scalars and vectors. Thank you so much for listening. I hope you enjoyed it. If you did and you want to learn about other cool physics facts, then please like and subscribe and watch all of my other videos. And if you want to learn about a specific topic, please leave a comment below and I'll try to do a video for you.